475929. 475929. Correct? Times x over y times x divide y. So for the first pair of data, we have one estimate of electricity, and then we can do the same for other variables. So that's, for this data, for example, we can have 11 different estimate of electricity. Okay. Or alternatively, with the average of x and y. So considering, so this one, which value of x and y to be chosen, considering data set used for double lock model, there are 11 pairs of x and y. If we use all of them, then we will obtain 11 different estimate of electricity. In practice, however, electricity is computed at mean or average of x and y values. With this we obtain the estimate of mean electricity for the given data set. So we take average of x, 1.01, average of y. We get the bottom of the Excel, so we have 2.206. Okay. So we use that values and then we calculate. We get using these values, the estimated electricity is negative 0.19921. Okay, this one. So it is slightly different to the estimate of electricity that we obtain through the use of double lock model. Double lock model we get direct estimate, but if you use this one, meaning that you want to estimate electricity using the normal regression, yes you can, but you have to do some calculation. You have to get the estimate of slope and then multiply x, for example, average of x over average of y. So it requires calculation instead of direct estimate. So these values differ from the value obtained based on double lock model, which is negative 0.2531 as given earlier. Okay, this one. So the two methodology give different estimate of electricity because the electricity based on double lock model remains the same, as it does not take into account the price of which it was estimated, whereas electricity based on the definition depends on the particular mean value. Okay. Now look at an example of the use of semi-log model. The one double log model, we apply log transformation for both dependent and independent variable, and then we interpret as electricity. So now for semi-log model, in particular the log linear. So meaning that we apply log transformation for dependent variable, but independent variable we use the original values. The use of log linear we can use to estimate growth rate. So as I explained in semi-log model section, semi-log model are commonly used to estimate the economic growth. In fact, its application is not only limited in estimating economic growth, but also applicable in measuring growth rate of other economic variables. Suppose we would like to determine the growth rate of real gross net product. So in the US for period from 1972 to 1991, let YT the real GNP at time t, and Y0 is the initial value of the real GNP. So we have the variables, dependent variable, but we need to create time frame variable. So this one is not the data that we collect, but we have to create a time frame. Then a time frame variable is the data that we create. Okay, the data intersect dynamic variable, but it's not 0 and 1, but it's sequence of value 1, 2, 3. So it represents the first observation, second observation, or represent time lah. Time number 1, time number 2, time number 3, time number 4, and the last one. Okay. So now recall the formula of compound interest you have learned in previous. If you learned before lah. So remember how the compound interest is calculated. if you learn about how to calculate the compound interest, you have a formula. A is the amount after a certain period you invest your money. For example, so you say you have a principal value of investment, and then 1 plus the interest rate, and how many years. Let's say you receive dividend, for example, every year, once a year, for example. So let's say you want to know how many, what is the amount of money you have at the end of the period. So this one is given the value of, for example, you have, let's say you invest 100 ringgit, and then that you invest in a money trust, for example, they give you 5% interest annual per annum, let's say for 10 years. If you calculate, so you get after 10 years, you should be able to get, you solve this, you get 162. So basically using the same idea, but in this case, we have the data, but we want to estimate. This one we know the interest, the rate, interest rate. But this one we don't know. Here we want our objective, we want to estimate the growth rate, just like interest rate. Okay, we want to estimate here. We know the last value. This one we don't know. Here we want to calculate the last value. But this one basically use the same equation. But here we apply just like regression. But this one our objective different. We want to estimate the growth rate, which is the just like interest rate here. So here we know the last value, the value of y, dependent value. This one we don't know the last one. We just want to use this formula to calculate the last amount of money after 10 years. This one we have the values of variable from the first year, second year, of the last one, and then we know how many years. We know how many years, but we do not know the rate. So we want to estimate the growth rate. Then we want to estimate the growth rate. We use the same similar equation, but the problem is now this equation is not linear in parameter, so we have to linearize it using a log function. So we convert. Okay. So where t is the compounded rate of growth for y, the a is natural log form, so we use log transformation, log of y, and then this one log of y0 plus t log of 1 plus r, and then now let this is our intercept, and then this is our coefficient, and this is our variable, dependent variable t. Okay, so we have this one. Okay, log of y. So this is semi-log model because our dependent variable log of y, but our dependent variable just time trend without log. So just a sequence of values 1, 2, 3, 4, and so on. So this semi-log model or log linear. Log linear. This is log linear because dependent variable using log transform value of y, but the dependent variable the original value of time trend t. So adding in error term, we get the model. So just again, don't confuse them. So here we use epsilon, but doesn't matter. Previously we use u as error term, but doesn't matter. So as long as we know that A is for representing the error term. So t represents a time trend. Suppose the first one t equal 1 for the first year, and then the second one, the second year t equal 2, and so on. The final model is known as semi-log model because some of the variable is in log form. So before we look at the regression output, let us examine the characteristic of the model. In this model, the slope coefficient, beta 1, measures the constant rate of relative change in y for a unit change in the regressor. So it represents a relative change. This one, it gives us a relative change. Remember, relative change means that it just like before you multiply 100. Percent change is after you multiply 100. Relative change before you multiply. You call this one I mentioned before. Example I gave before. If you just take the difference between two divided by original one, it is a relative change. If you multiply this with 100, you get percentage change. So the one that given here is represent estimate of relative change, not percent. So in order to interpret a percent, you have to multiply by 100. Okay. For log linear. Unlike double log one no need to multiply. You can just directly use the estimated value and interpret a percent. But this one, if you want to interpret a percent, you have to multiply with 100. Okay, because the estimate gives us relative change, not the percentage change. So the estimate of beta one gives us relative change in y for a unit change in x or time increase x or t. So not percent. In order to interpret percentage change in y, you have to multiply 100. Okay. So the change in y per unit change in x. If we multiply the relative change in y with 100, we will get the percentage change of growth rate in y for unit change in x. Such models are very useful in cases where x variable is in the form of time, as in our GNT model. The model describes constant percentage growth rate if the coefficient positive, or declining rate if the constant, if the estimate negative estimate of parameters, so in y. So this y is what is known as growth model that allows us to estimate the growth rate, okay, over a period of how many years the data covers, and then how the average, what we call it, give an estimate of the growth rate for 1 year. Average, just like average growth rate for every year. If you go back to the example earlier, okay, another one. So this one is number 2. Semi-log, log linear. This one. So our dependent variable in log form, log of y, our dependent variable x original values, just like t lah. Okay, just example just now we use t instead of as our x and trend as our regressor x. Yeah. So you see, in terms of our interpretation of the slope represent what? The slope represent the amount of the average change in log of y per unit change in x, because x original values. Remember this one? It gives us estimate of average change of log of y, average change of log of y, not y but log y per unit change in x, not log x, in x. So recall that this gives us similar estimate of, or give us an approximate value to the relative. This is equal to relative change, right? The difference between two value of log give us approximate value of relative change. This one relative change, the difference between y over unit y, relative change. Okay, per unit change in x. So if you want to interpret a percent, you have to multiply the 100 lah. Then you can interpret a percent. So you can say that percentage, how many percent change in y per unit change in x after you multiply the estimated coefficient with 100. So unlike log linear before, because both above, upper and lower you have times 100. So whether you multiply or not, you get still get same. Okay, so it doesn't matter whether you multiply or not. The log linear, double log model, you don't need to do. You can just take the estimate as direct estimate of it still, because you can just simply just the same value. So you multiply. Remember this one before? Whether you multiply or not, you get the same value. Okay, so for double log model, you can just take the estimate as you can interpret as elasticity, because you multiply or not, you get the same value. Okay, so this cancel out. This. Yeah. But for the case of log linear model, If you do not multiply, then it only gives us relative change, not percent. Relative change. So in order to get a percent, you have to multiply 100. Okay. So you have to understand this one. So you understand, no need to memorize whether you should multiply 100 or divide 100 and on. For linear log, linear log model, you have to divide 100. This one multiply, give log linear. So referring back to our example, we can write the fitted equation as this. The interpretation of this model is as follows. During over the period of how many years that one? From 1972 to 1991, the real GNP in the US grows at the rate of 2.469% per year. So although estimate here 0.024, in order to say percent, you have to multiply 100, so you get 2.469. That's one. Estimate here 0.02, but it's one 2.4, because if you want to say as percent, you have to multiply 100, so you get 2.469. Okay. So taking the antilog of the intercept 8.0139 x1 and x1 of the value, we get the estimated GNP. At time 0, that is at the beginning of, before, meaning that at the beginning of 1972. So you use antilog, you use the exponent of the value, so you get 3023. So estimate of the initial, so the value we have here is the value of GNP at the end of 1972, not the beginning. So you want to get you want to have the initial value at the beginning of 1972. So you antilog this one. You antilog the use the exponent of this when t equals 0. So you get 3023. So we get the estimate of the initial value at time t equals 0. This one times 1 to t equals 0.